And the function of the straight line is y equal mx plus b. Let's see the extra credit. In this section, we describe the general method known as the method of least squares for determining a straight line in that, in some sense, best fits a set of data points when the data points are scattered about a straight line. I'm glad you asked. So let me tell you, what do we mean by best fit line? Like, what does it mean by best fit line, and how do we find it? Here is a data set, a very small data set, only 5 points there, right? The x-axis is the size of the apartment. The y-axis is the cost of the apartment per month, right? So you see a positive correlation between the size and the cost, right? In general, you have bigger apartment, it costs you more, right? And of course, that depends on location too. Like for example, that this, for example, this point right here, it have a smaller size than the third point, but it's cost more because of location. But in general, bigger size costs more. Now, if I ask you to draw a line that simultaneously closes to all the points at the same time, how would you draw that? Right. Student one probably draw like that. While other student maybe I like it, maybe like that, right? Other student maybe in between. So which one is the best one to represent all those points? Now imagine I draw a line. I'm just gonna arbitrarily draw a line. Draw a line here. I don't know if it best fits line. I don't know yet. Just draw a line. And what I'm going to do next is I'm going to draw a distance from the data point to the line. Not very. Oh, that's point. Just that's why it's maybe down here. All right. Okay. In statistic, when you see those distance, they call the error. Those are error. The error between the real data point and the estimate data point, which is on the line. So those are error. Now, what I'm going to do next, I'm going to draw a square around those points with the line. So what I'm going to do next, I'm doing this. Of course, it's not perfect. My square is not perfect. Square. And what I'm going to do, so here's my D. I'm going to call these a D, the little, so D1, D2, D3, D4, and D5. By the way, these are squares, okay? I know it doesn't look like a square, but just square, okay? They're square. Square. Say the area of the first square will be what? D1 square, right? D1 times D1. Right? So the area of first one will be D1 square. The area of the second square will be D2 square plus D3 square plus D4 square plus all the way to the last one, which is D5 square. If I add all those square, and it'll be the smallest one, it will be the smallest sum, and I sum them up. And that sum supposed to be the smallest one, smallest value, then I can say that this is my best fit line. Why? Because the distance between the real point and the estimate point on the line, they're the shortest, right? So you have less error, right? So if I have some auto square and it's the smallest value, as opposed to somebody draw something like this, if they add up all those points, all those area, but it's bigger than the one that I had, the red one, then it's not the smallest values. Then I call this is the least square line. Why? Because that's how the method. Basically, you add up all the square, right? The smallest sum of the square, 10 squares. So the best fit line is the line that gives the smallest sum of square. Hence the name best square line. Do you know why it's called x to the second power squared, right? Don't write this down. We call the x squared. We don't say x to the second much, right? Well, x squared because it represents a square. X times x, that's the area of a square. Right? If I have a square and then, oh, my square. If I have that square and then this x squared. Why? Because back in the day, when we don't have computer, we use geometry to represent algebra. So a lot of term we use nowadays is kind of related to geometric expression. Now, how do I find this? How do I find this best line? Very simple, really. Suppose you are given n data point. This has to be given. You're not guessing it. It's given. If you want to find the linear best, the best linear line, which is in this form, then you need what? You need a slope and you need a y-intercept, right? M and B. How do I find my M and how do I find my B? Well, here are the normal equation. They call that a normal equation, and that's statistic. You don't have to know why normal equation, but in mathematics, it's translated like that. Remember, your variable right now is you looking for B and you're looking for M. Why M plus B? You know N, right? N is given. N's always given. Well, if N's given, then they are data points, right? Then X1 given, X2 given, Y1 given, Y2 given. So all of these are given. You plug it in, you have a system of two linear equation. You guys know how to solve for that, either by substitution or elimination. So let's take a look at the example. We have to, given the data, how many data points do I have here? 4, right? So N is 4. 4 pairs of X and Y. What I'm going to do next, draw things on the right. I'm gonna make a little table. X square, and then Y. X. So I need X. If you look at the normal equation, we need we need x squared, and then we need x times y. So x, I need x squared, well, and then y, and then xy. X will be what? X will be 1, 4, I'm sorry, 1, 6, no, 1, 2, 1, 2, 3, and then 4. X, Y, X, Y, X, Y, X, Y. And the Y will be 4, 6, 8, 11. X squared. 1 square is 1, 2 square 4, 3 square 9, 6, 4 square 16. X times Y. 1 times 4 is 4, 2 times 6 is 12, 3 times 8 is 24, and 4 times 11 is 44. And then what you're going to do next, you're going to sum them up. FYI, notation for sum is capital sigma. That's in Greek. Capital sigma. 1 plus 2 plus 3 plus 4, that's 10. You're going to sum down in the column. 1 plus 4 plus 9 plus 16, that's 30. And then 29, and then 84. So far, so good? Yeah. Let me write out the normal equation. I just write out the formula from up here, that's all. N times B, I'm gonna write thing in red, the one I'm looking for, plus x1 plus x2, how many x here? 4, x3, x4 times m equal y1 plus y2 plus y3 plus y4. And then the second normal equation will be x1 plus x2 plus x3 plus x4 times b plus, I'm lazy because I'm duplicating thing, plus x1 square plus x2 square plus x3 square plus x4 square times m equal x1 y1 plus all the way to x4 y4. I'm run out of space, so I'll write like that. Right. N is 4. Let me write red. I am just so it's a lot of work trying to keep up with the color. N is 4. And then the sum of x1, x2, x3, x4 is 10. Right. 10m equal the sum of y, which is 29. And then the second one, sum of x times b, which is 10b. I'm sorry, yeah, 10b plus the sum of all the squares, which is 30, plus the sum of all the products, which is 84. So that's okay. It's very simple process. It's just a lot of numbers, but they're simple. All right, I'm gonna use elimination to solve all this. You could use substitution if you want. I'm gonna multiply both sides by -3. Why I want to multiply by -3? Because I need to eliminate one of the variable. And I choose M to eliminate. So I had positive 30 on the bottom. I need minus 30 on the top. So this becomes negative 12b minus 30m equal 29 times negative 3 is 9 times 3 is 27, 80, negative 87. And then rewrite the bottom equation. Let me add. Negative 12b, positive 10b is negative 2d. That one cancel. It has to be because you wanna go reduce down to one variable. Equal negative 3. Really? Yeah. Okay. So b is 3/2. That's my y-intercept. Once I have b, I can substitute back into one of the equations. I'm gonna pick the first one because it looks smaller. So 4 times 3/2 plus 10m equal 29. Bless you. 4 going to 2 times, so 2 times 3 is 6. Plus 10m equal 29. Subtract 6. 10m equal 23. M is 2.3. The best fit lie is y equal 2.3 x plus 1.5, which is 3/2 there, 1.5. Later, I'm going to show you how to solve system of equation using matrix with calculator too. But right now, just do by hand. The part B, they want to draw. Yes, Mike?
How did you, can you go back to how you solved that equation? No, on the previous page. That one.
You want to take a picture of that?
No, I mean, like, how did you go from 4b 10b to negative 12?
How do, say it again? You kind of breaking up.
How did you go from 4b and 10 to 12?
Still can't see you. Oh, you mean how do I get this one? Is that this one you asking?
No, I meant put 4b 10b. How did you get to negative 12?
Oh, I combine. So okay, so I'm gonna highlight in green here so you can see. Look at this function. Can you see what I'm highlighting?
Yeah.
I multiply that function by -3. So everything 4b 10m 29 gonna be a negative triple. You're gonna triple it. So 4 times -3 is -12.
Yeah, that's okay. I see
10,
it.
yeah, 10 times -3 is -30, and then 29 times -3 is -87.
Okay, got it.
That's called elimination. Here I'm eliminating m, so I need a opposite coefficient for m. All right, part B, we're gonna graph this. So on the x-axis, I need all the way up to 4 is the maximum, right? So here, 1, 2, 3, 4. On the y-axis, I need up to 11. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You plot point? 1, 4. Right there. 2, 6. Right there. 3, 3, 8. And then 4, 11. They're not supposed to be straight, guys. It'll be very perfect if it's straight. In real life, there's nothing perfect, right? And then that's my real data point. Now I'm gonna graph my least square line. Maybe I'll highlight in blue. That one. Wait, that one. As you can see, the y-intercept is 1.5, and then the slope would be rise over run, right? Rise 2.3, run over 1. So 1.5 is roughly here. I'm gonna rise to roughly 2 unit, 2.3 unit, right there, and run over 1, right there. I only need 2 points to graph a line. Oops. Something wrong, hang on, something wrong. My best fit line does not look like a best fit line at all. Oh, I know why, because of the scale. That's okay. No, we all right. If I want to make this skinnier, it goes steeper, but that's okay. We're doing right. That's your least square line. I want you to try the next one on your own. I'll walk around, see how you do. Maybe I'll give you a few minutes. Do you guys take SAT or ACT? SAT? They don't do ACT anymore, do they?
I think it's like optional.
You have a choice.
Oh,
I did easy.
yeah. How do you know you like which one better?
I took the pre-SAT and then I took the actual ACT, but the ACT was like more math. You know?
Oh,
I
okay.
think the ACT takes more preparation. SAT.
Mm,
People still do the ACT over
yeah. I know in Michigan, they've prioritize one of the two, which is SAT. But I didn't know that you still have option. You take another one.
Yeah, I signed up for both, but I still got canceled for the year.
Mhm.
through my junior year. So,
And what year was that?
Hmm?
What years did you took it?
oh, I took it 2020.
Okay, recently. All right. I'm from Vietnam, so we don't have SAT or ACT. We have by the end of 12th grade, you have a general test. It's gonna test from 10th grade to 12th grade. So all the material from 10th grade to 12th grade. And then in order to get into university, you have another test. That test for university to decide. I'm glad I don't have to take the test against university because it's hard. All right. So first, you need to identify what is your how many n you have here. What is your sample size? 5, right? Thank you. 5. And then determine your x and your y. Oh, by the way, yeah, you have your x and your y. Maybe I'll do it here. X is 1, 2, 3, 4, 5. X squared will be 1, 4, 9, 16, 25. Y is 436, 438, 428, 430, and 426. X times Y. 436, A76. I have in my note A76, 1284, 1720, 2130. Remember the last one is x times y, not y squared. Careful. And then you sum them. Summation. 15 here. For the x column, for x squared will be 55. For the y column will be 2158. And then for the x times y, is 6446. NB, N is 5, NB, plus plus the sum of all x times m, and then equal the sum of all y. The sum of all x will be 15m equal the sum of all y will be 2158. And then for the second one will be the sum of x times b. So 15b plus the sum of the square times m, the sum of all x squared. So 55m equal xy, sum of xy. So 6446. On the exam, I'll give you the formula, okay? You're not memorizing that. What variable you want to eliminate? Yeah, pick something easy for you. Right? You can eat MB and doesn't matter, but pick something that makes your life easier. Okay, so what should I multiply the first equation by? -3. Right? And it's not always -3. I know the previous example is always -3. It's just coincidence. So I have -15 p minus 45m equal my notes, so I don't have to pull out my calculator. -6474. And then write out the second one. Then you add. That's cancel. -45, positive 55, that's 10m equal make sure yeah, equal -28. So m equal -2.8. Now you find b. I'm gonna use the first equation because it looks simpler between the two. So 5 times b plus 15 times m. M is -2.8 equal 2158. Five b plus, or rather minus 42 equal 2158. Add 42 both sides. 5b is 2200. So b is 440. So my best fit line is y equal mx plus b. M is -2.8 plus 440. The equation is so simple, but it's a very powerful function, linear function. I spent the first year of my grad school to study linear function. Well, in statistics, it's called best fit line. That's all we studied, really. We just beat it around the bush. It's a very powerful function because easy to work with. Let's draw this. So if you look at the X and Y, the scale is crazy. Right? X is pretty straightforward, but the Y scale is huge. Okay, so let's see, I'm going from 226, I'm sorry, 426 to 436. All right. Let's do the X first. 1, 2, 3, 4, 5. Here's my 400. 410, 420, 430, 440. I'm gonna do a little zigzag here because I know there's a lot. It's a lot longer than this. Right. All right, let's plot the point first. 1 and 436. 1, 436. You try to plot it yourself, really. Be helpful when it comes to the exam. Right there. Right there. So I'm not satisfied. Right there. 2 and 438. Slightly higher. 3 and 428. Go down. 4 and 430. 5 and 426. Let's draw the best fit line. Okay, at this point, I hope you don't guess it. Right? You have one. Use it right here. The y-intercept is 440. That's my y-intercept. And then rise over run. You rise down 2.8, run over 1. Right? So basically, 2.8 is you going nowhere, isn't it? To the scale. Well, actually, you can go down a little bit, just tiny a little bit, slightly, and then run over 1. Right there. That's your best fit line. It looks better it looks better as compared to the previous problem because the scale, they kind of similar. As before, we had longer scale on the x-axis and shorter scale on the y-axis. Part C. Assume that the trend continue, meaning to keep going down like that. Estimate the average SAT score, SAT verbal score of high school seniors 2 years from now. 2 years from now, so T should be equal to what? Two years from now. Now is 5. 7. Right, 7. So basically you put in f of 7 equal negative 2.8 times 7 plus 440 420.4. Unit score. Wow, that's not good. Oh, that's not good. They will get doing worse. I hope it's. I hope this is it's a real data though. Goodness. All right. I hope it's not Metro Detroit. Not good. Facebook user. How many people here have Facebook account? Almost everybody? No, not me either. I used to have one, I couldn't handle it. Too much. Took up all the time. All right, let's do this one. X is equal to 0 to note 2018. So here's 0, 1, and 2, and 3. This is our last problem. You know, I'm kind of lazy, so I'm gonna do this. So that's my X. That's my Y. My X squared right there. All right. Here's my XY. It doesn't matter. You can do the table like I did. X squared, 0 squared, 0, 1 squared, 1, 4, 9. Right. And then Y, XY will be 0 times 15.4.5 is 0. 1 times 381.8 is 381.8. And then the next one will be 1309. And then 2535. Sum of X squared, 14. Sum of X, 6. Sum of Y, 2035.8. And then sum of XY, 4, 42 to 25. Someone come up with a system equation for me. Well, n how many n here? 4, right? So n is 4. So add b, right? I forgot that you forgot. You don't have the formula. I'll do it with you. 4b plus the sum of x times m. So that'll be 6m equal the sum of x squared, which is 14. Then the second one will be the sum of x times b, which is 6b. Oh, you know what? My bad. The sum of y here. So it'll be 2035.8. Sorry about that. And it will be the sum of x squared right here. That'll be 14m. I'll give you a formula, don't worry. So 42, 25, the last one. Which one you want to eliminate? they kind of equally same type of work, but in terms of LCD, I prefer B. Yeah, 6 and 4 is easier to imagine than 6 and 14. What should I multiply the first equation by? You guys have to do both. They have to be opposite. What's the LCD between 4 and 6? 12, right? So multiply the first one by 3, right? And then the second one by -2, or -3 and then +2, doesn't matter. So 12b plus 18m equal 6,107.4. And then the second one will be -12b minus 28m equal -8451.6. I know today lecture is kind of boring, but it's a good thing in terms of your exam will be easy, right? B cancel. Yeah, it had to be. One of them has to be canceled. If it not, something wrong. 18m minus 28m will be minus 10m equal -2344.2. I think the only problem you're gonna make on the exam is arithmetic, really, for these problems. Just be careful, that's all. Divide both sides by -10m equal 234.42. Right. And I'm gonna plug it into the first problem. I mean the first equation. 4b plus 6 times m. And m is 234.42 equal 2035.8. 6 times 234.42 is 1406.52. Subtract 4b equal 629.28. Divide both sides by 4. B is 157.32. Your final answer, the best fit line will be y equals 234.42 times x plus the y-intercept will be 157.32. Yay! One more. This is one more question, not one more problem. One part B. Yeah, I'm getting tired of doing these too. Use the result of part A to project the number of Facebook users at the end of 2015. Assume the trend continues, and it looks like it continued, right? Before Facebook, there was MySpace. Okay, did you know that? You got too young to know that, maybe. I had MySpace. I like MySpace. Not so much Facebook. All right. MySpace more like a blog. It looked like a blog than a social platform. 2015. Where do we stop? We stop at 2011. So 2015. X gonna be what? 7. Yeah, 7. Yeah. Again, coincident, not always 7. What user plug it in? Let me tell you the happy ending. $1,798. Oh, come on. I keep touching it. 0.26 million user. Is in million, right? It's crazy, yeah. Million user. Wow, a lot of users that we know of. That we know of. All right. All right, last lecture, last slide, and now I'll let you go. This is true, false. It'll be quick. Number 3 is your extra credit. But we're gonna do 1, 2, 4 together, and then we'll go. Think about it. Determine whether the following statement is true or false. The least square lines must pass through at least one data point. True or false? False. It doesn't have to be, right? It's as long as my what has to be, as long as my sum of squares is smallest, right? So false. The error incurred in approximating n data points using the least square linear function is 0. Remember, error is a little distance between the point and the line. If and only if the data points lie on a non-vertical straight line. Do you understand this question? So I'm saying that my error is 0 if all the data points is lie on the vested line. True or false? Okay, I just tell you the answer really. If they lie on the line, is there a distance? No, right? So 0, right? So true, right? True. I think the problem for number 2 is you gotta understand what it's asking you to do. Number 3, that's your extra credit. Last one, a data point lies on the least square line if and only if the vertical distance between 2 points and a line is equal to 0. The data point lie on the least square line if only if the vertical distance. Oh yeah, true or false? It's the opposite of number 2.
Isn't it false?
No. Not opposite, but it's the same thing as number 2. True, right? Number 2 say if all the data points are lie on the line, then the error is 0. Same thing. That's so true. That's your homework question. I'll let you answer number 3. I don't want to get all the fun out of it.
Not public. Credit.
Huh?
It's not public.
It's not. It's okay. Let me in. Oh, so sorry. I need to show you. Show. Okay. If you refresh your Moodle, you should see it now. So I hide it from you. Sorry about that. And then when you're done, you can leave. Have a good one, and I'll see you again on Friday.
On Friday, do we have a quiz?
Yes.
What is that on? Is that just on?
I'll send out email.
Okay.
Yeah, because people keep asking the question, and I end up telling you the.
It's true.
For some reason, I can't find it under extra credit.
You have to refresh it. Oh, this is how it does.
Have a good one.
You too, bye. Go to the Safari. Sometimes the
Have a good day.
you too. Sometimes the app is not. Yeah. You too. Bye bye. Bye.
Yeah, I have a question on my homework from last night.
You found it? Oh, sorry.
It's the only part that I don't understand. What does it mean when it says state the degree of polynomial functions?
So the degree is the highest. Is the highest degree. Okay. Let me see. Oh, you can watch it.
Yeah, but when I watched it,
Uh-huh.
it did the first part, but it stopped at the second part. It doesn't explain
Really?
how to
You
find
tried
it.
DNA.
Huh?
No, but like,
Given the
how do you
parameter.
find it? Though?
State the degree of polynomial. I forget. I wonder if it. I think the highest degree or the all the degree adds together. I forgot. Let's see.
It stops before
Yeah.
it explains, but it just says if it's rational or polynomial.
Oh, that's it. Hang on. Let me see. Oh, you can you can reduce this. So x squared minus 4 is x plus 2, x minus 2, right?
Right.
And you cancel one of them.
Oh,
So the answer will be x plus 2. So the degree will be 1. X plus 2.
so it'd be 1?
Yeah, you know why 1, right?
No.
You
Oh,
ca-
'cause
you
you
factor,
cancel.
yeah, you cancel one of the x minus 2 on the top,
Okay, so then you're only left with
x
1.
plus 2.
Okay.
So x plus 2, what the
So-
degree x plus 2? The first degree, right? That's
Yeah.
your linear function.
Right.
Mhm.
Okay.
Yeah.
So then it'd be 1.
Mhm.
No.
Why is not, if the answer is why is not 1? That's ridiculous. Are you sure? Read the problem and consider what type of function was given. It's linear. It reduces, it's linear. X plus 2, x minus 2 is x plus 2.
Isn't rational always DNA?
Hmm?
Isn't rational always DNA?
Does
Oh.
not exist.
But you can reduce it. This one you can reduce it. What is it 2.7?
Yes.
Let me see.
Hey, can I give you this form?
Yeah. What is that?
I'll miss class Friday because I'm student manager for basketball.
Oh, okay.
And so,
Oh, this Friday?
yeah.
All right. Email me though. Okay. Email me so
Oh, okay.
because there's no makeup quiz, so we had to figure out something.
Okay.
Yeah. So email me and then we'll figure out something.
I'll do that. You have a great day.
You too. Go to my lab lesson. Number 1.
Yeah, number 1.
I don't get it. It say D and E, but when you reduce it, is
Is it because it's rational?
yeah, it was rational in the beginning, but when you
Oh.
reduce it, it's yeah. This is a good idea. Yeah. Oh, sorry. I know what's D and E.
Oh.
The polynomial function. It wasn't
Oh,
polynomial.
Oh.
Yeah.
Okay.
Tricky. Yeah.
So I
Yeah.
have to.
So so your answer A was rational.
Yes.
So it was it wasn't a polynomial to begin
Okay.
with.
So then for this one, since it is polynomial, I'd reduce it.
So you're gonna
Or-
expand it.
Oh.
So let's see, you don't have to spend it all I need is the leading degree.
Okay.
So x squared and then 4 outside, we x to the 8, right?
Yeah.
So degree will be 8. Mhm.
Oh, okay. So I'd combine them.
Yeah, yeah. Yeah,
Oh, okay.
it's tricky,
And then
it's
so for
polynomial.
negatives, I do the exact same thing.
No,
I say-
it's not a polynomial. Right? It's they state the degree of the polynomial.
Oh,
It
so it'd
wasn't a
be D-
polynomial. Yeah, D and E.
D&E, okay. All right, okay.
Yeah,
Thank
sure.
you.
I don't know why they did that.
Just a real quick, question. For the problem that we did in the class, if n is equal to like how many data points there
Yeah.
are,
X, Y, here.
if we had 4 data points on this last problem we did, even though it's 0, 1, 2, 3, 0, 1, 2, 3,
Then 4.
wouldn't it have been then 8? Because we're adding that 4-year difference to the n and not like the actual data.
No.
It is, okay,
No, your vested line is based on this data set. you've
Okay.
done.
okay.
And you say, okay, based on the information that you've given,
Mhm.
if the trend continue, you're gonna use that line to predict.
Yeah, no,
Yeah,
that part,
yeah.
excuse me, made sense. It was just the difference between this one and the first one we went over in class. Cause it goes 0, 1, 2, 3. I get the simple math.
Yeah.
I just, when we added 2 to the last one, it was 5, 7, and then this
Yeah.
one was 4.
Oh,
You see what I'm saying, the
2
confusion?
what
So
do you-
I thought it would have been 8, not 7.
so 2000, 0, 1, 2, 3, right?
Yep,
And then 2012 will be 4, 2013 will be 5, 2014 will be 6, 2015 will be 7.
no, and I get that. I took it as when you taught us it, it was whatever the new, like how many years passed
Oh, because you
after
start with one.
plus n.
Because you start with 1.
Yeah,
Yeah,
so-
here we start with 0.
Yeah, no worries. That's, I just want a clarification on
Oh,
that. Yeah,
okay.
yeah. Thank you so much, sorry.
No, sorry, I didn't understand your question. Sabo.